Let me know if you can see my screen.
Yes, sir.
Okay. So
Yes, we can see.
good, good, good. और जहां भी जिस पॉइंट की समझना है प्लीज में रोक देना and we will discuss in detail. Now, what is assembly language? Well, basically, as far as assembly language is concerned, it's one of the low-level programming languages that you have. Previously, if you do know what a compiler is, and if you know how to distinguish between a compiler and an interpreter, basically compiler does it in one go, okay? And compiler basically does is that it converts the source code into the object code. Interpreter does it line by line, okay? So the interpreter is slower, compiler is faster, but at times you need interpreter, at times you need compiler, depends on the situation, okay? Well, that's not
Sir,
yes.
so what is a low-level programming language?
Low-level programming language is better, that is which is understood by the hardware, the machine. For example, if you want to communicate with the RAM, if you want to develop an embedded system that uses very specialized hardware, obviously it has to be converted into low-level language, because hardware will always understand binary language, machine code, which is 0 and 1s. And the problem with humans is that we cannot program with zeros and ones. We had to have a language that was easier for us to understand, which was like Java, C++, Python. These are all your high-level languages. So high-level languages are those languages which are understood by humans easily. Low-level languages are those languages that are understood by computers easily.
Thank you, sir.
No problem. You keep on asking questions. I appreciate that. There had to be a language that was somewhere the middleware language that would play the intermediate role between both of them. Assembly language is one of them. Yeah, obviously, understanding the mnemonic, the instruction code for assembly language, it's not very easy for everyone to understand. You need to write lots of codes for just a simple instruction to take place as compared to a high-level language. So not everyone becomes an assembly language developer. Those people who want to go into embedded technology will prefer using assembly language. Okay, so assembly language is a totally different thing. When you will go into your university, you will get one of the semester in which you will be doing assembly language in much more detail than the A-level program. In A-level, we don't discuss to a lot of extent, but yes, we do a lot still. That's why I'm cutting down this lecture into 2 different days, not to complete it today. I could have completed all over today, but I don't want to confuse it in one day. So let it be in 2 days. It's different. So it's a language.
Sir,
Yes, better.
sir, so you said that compiler converts from source code to assembly language.
Compiler basically converts your high-level language code into your object code. Okay, so basically high-level language into low-level language, you could say. Okay, but compiler basically does it. It compiles it in one go. It reads the entire code, whether the code consists of 10 classes, it would read it at once and then it will translate it. The problem with compiler is that if there are any errors, obviously it will give me a bunch of errors and I have to handle with them. The advantage of interpreter is that it will go line by line. It will tell me first, it will execute one class and it will tell me the problems in one subroutine as in function, and then it will tell me the next one and the next one. So it's easier for the programmer to handle any debugging in case of an interpreter as compared to a compiler. Okay, but if you have a program that is quite lengthy and you might think it will take a lot of time for me to interpret it, I would probably choose a compiler. And if I'm sure that my bugs are not that much, I would go for compilation rather than interpreting, because I don't want to like have a look at each and every bug. Maybe I can leave it to someone else. So it depends on the situation. It's not the point for argument for right now. We will discuss in the later chapter. So in computer, there's an assembly that helps to convert an assembly code into a machine code executable. Okay, right? Assembly language basically is designed so that the computers can understand, the machine can understand, so that they can start with the further processing. Today lecture, we will be talking about the different kind of operation codes that there are, the typical one, okay? So basically, it's mostly concerned, your assembly language is mostly concerned with the working of the architecture of the system, which means it's a language that can be used for the hardware to understand, okay? Because it will be much more faster for it to be converted into binary language. High-level language will take more time to be converted into your machine code. So it will be more time consuming. This is one of the advantages of assembly language, that it's much more faster. If you compare it with high-level language, assembly language works much faster. The execution takes much faster. The compilation takes in a much more faster way. So there will be these mnemonic processes we will understand. There will be statements and instructions. Okay. Okay. It is produced with the help of compiling the high-level language course, such as C language. Assembly language helps in fine-tuning the program. इसको मैं explain करता हूँ. So I just talked about it, why assembly language needs to be used. I told you that it's difficult for machines to understand high-level language. So assembly language gives full control to the person who is trying to work with a particular computer architecture. So it basically gives a lot of control to that particular person. So like I said in the beginning, when I mentioned that high-level assembly language is used for embedded technology, this is very important. By embedded technology, what I mean is you want to create a very good control system for your home automation, and you want to develop your own system. So for that, you need to learn how to use assembly language. If you want to directly get in touch, communicate with your actuators, with other parts that are fitted within the motherboard, obviously, assembly language is much better for you to work with. So yes, there's a lot of scope of assembly language, no doubt. Okay, I've just talked about all this. I'll share with you later on. Have I missed any point? So yeah, speed, like I said, it mainly helps in speed optimization that increase the efficiency and performance. Why am I saying that the speed increases? Because obviously, if we talk about, let me go further and no, let me explain like this way. If I have to convert from a high-level language to a machine code, it will obviously take me more time. But if I am there using assembly language, which is much more closer to my machine code, so the fetch execute cycle between the assembly language and the machine code will be much more less, and there will take much more less time. So I would be able to convert it really faster. So that's why assembly language tends to be much more efficient, and the performance keeps on increasing more and more. So this is the way we prefer using it. Yeah, but obviously the code that needs to be remembered is much more complicated as compared to your other languages. It helps assembly language, like I said, it's helped us to debug in a very easy manner. Okay, that's why we should use it. Now, as far as the features are concerned, obviously there are these mnemonic that we will learn about. There are two things that we will talk about today: is the opcode and the operand. The opcode basically will be the short for operation code, that a part of the machine code instruction that identifies the action the CPU will take. For example, if you might recall, while we were discussing chapter 5, I did discuss with you is some commands such as load, jump. Okay, so these were your opcode. Jump to the next instruction, load the following file, out, display this out, so on and so. So we'll talk about all these instructions today. The operand will be the part of the machine code instruction that identifies the data to be used by the CPU. Now, this data that has to be used by the CPU, this could be data. This could in fact be the address as well. So keep this in mind. It could be the data and it could be the address. So advantages, these should be in your mind. You should know them. You should be able to list them down. So I have made a list of them. The advantages, it allows complex jobs to run in a simpler way. it's more efficient, it's more faster as the execution time is less. Okay, I have basically the memory, okay, it is memory efficient. It requires less memory. So within your registers in your processor, your assembly language will be using less registers, and so it will require less memory. Faster is different point, memory is different point. Keep in mind. So, okay, so execution is different point. Yes, Usman?
सर मैंने यही पूछना था, समझ आ गया.
Yeah, memory is different and faster is different. दोनों को अब differently मैंने लिखा हुआ है. Okay, it is mainly hardware oriented. Like I told you, embedded technology में wherever you want to totally communicate with the hardware, the actuators, the output devices, all those peripheral devices which are fitted with your motherboard. If you want to directly communicate with them, you want to work with assembly language. High-level language is more about developing systems that the common users might be using. That's totally different thing. Okay, here we are doing is we're trying to create an interface that will help us to communicate with the hardware directly. So
Sir?
Yes.
Sir, is assembly language understood by humans as well?
Yeah, it's understood. That's why I'm saying you can become an assembly language developer as well. But
Sir, does assembly language have to be converted to ones and zeros before it is understood by the hardware?
the assembler, yes, it has to be. Obviously, hardware cannot understand assembly language. Hardware will be able to understand only zeros and ones.
Oh, okay.
It's just that the conversion that will take place between assembly language and the machine code is will be much more faster as compared to between the high level language and the machine code. There will be more steps required, more execution required in that case, but over here it's very near. So if you put them into layers, your assembly language comes in between and your high level language comes at the very top and your machine language comes at the very bottom. So if you're in the middle, you will be able to communicate with the bottom layer very easily. So that's how we place them. Okay.
Thank you, sir.
No problem. It is mainly hardware oriented. It requires less instructions to get the result. Okay, I'm not contradicting my statement. Right now, I just said you need to type in more instructions, but that was something else. That is for that you have to type in lots of commands. But in order to communicate with the hardware, you need less instructions. Okay, I will be able to elaborate this point, let's say in the next lecture on Wednesday, inshallah. Okay, so it's not a contradiction to my statement that I just said right now. It's something else. It is used for critical jobs. Like I said, yes, it is critical because you will not find an assembly language programmer everywhere. Okay, and frankly speaking, you will not find organization using assembly language everywhere. Assembly language will be only used in those places where they are developing new motherboards, where they are developing new electronics, where they are working with digital electronics. So if you are into digital logic and design, if your electronics part of physics is really good and you really have an interest in it and you want to integrate your computer science skills to it, I think assembly language should be your choice. But remember, the job prospects are limited, but if they are there, they're very good. Because like I told you, the companies that you have are very limited that are developing this. You have them in Korea, Chinese are doing it. So obviously, wherever you will have these hardware development, they will be offering such kind of jobs. Because we will not be working with assembly language to produce an inventory control system for an ABC person. No, that's not the case. For that, we have Python, we have other languages. I hope you understand. So it is not required to keep track of memory locations. Again, I'll not discuss it right now. It is low-level embedded system. We'll discuss all these, the last points in the next lectures. So it takes a lot of time and effort to write code. Yeah, it does. It's very complex to understand. The syntax is difficult. Remember, lack of portability of program. Now, portability basically means that obviously, if I'm working with an IBM motherboard, and on the other hand, if I'm working with an Intel motherboard, the architecture will be different. So every architecture will differ. So every organization that will be creating their embedded system will be different. Like Samsung, when they create their own phones, they have an assembly language programmers who do it only for Samsung. If you have for Apple, they have their own. So obviously, one of the finest prospects that you have for assembly language is in the cellular technology, because that's also embedded. We call that embedded as well. Okay. It needs more size or memory of the computer to run long programs written in assembly language. So there are different softwares in which you can program assembly language. These softwares that I'm talking about, they basically take more space. It's not that the executable program I'm talking about. I'm not talking about that one. So programs that will do the assembly language programming for you, that they will take a lot more space. So obviously, for disadvantage, we need to talk about it, and you can mention it in the exam as well. Okay. The point that I take out, I don't randomly just mention on my own. They are there from the examiner as well. Okay, so you can obviously use them. Now, like I just talked about, at the very top level, we have the high level language, which will be just like Python, just like Visual Basic, just like JavaScripting. Then you have the assembly code, and then you have the object file that was converted, that contains the source code, and then you have the machine code. The reason why I'm trying to explain you this is that if you look at the compiler basically does is that it converts a high-level language into an assembly code, and then assembler basically converts it from an assembly code to an object code, and then you have a linker basically that links the object file to the machine code. The role of the linker, the most important role of the linker, is to integrate the library file. Remember the library file? When we were talking about IDEs, we always refer to the libraries. What are libraries? All those built-in procedures, all those mathematical comparisons, so all those built-in things that you have, they're held in the library. Why? Reusability. I don't want to create things on my own. So a library will hold at it. A good example of library would be, for example, like in Excel, you have built-in functions. They're built in within the library of Excel. Same case while we were using Access even, although it's a database software, we had some built-in functions within the queries of Access as well. So all these procedures, methods, the properties which are built in within these softwares, they are basically part of the library file. And using the linker, you can link them with the object file in order to make the machine code. We will be talking about all this in much more detail in P3. Okay, so obviously the extensive discussion of all this will be done in P3. I don't want to start all the discussion right now because it will lead to more confusion than saving our time. Okay.
Sir,
Yes.
what is source code or object file?
Okay. Basically, before your machine, your code is converted into a machine code, it is converted into an object file. An object file basically will be an executable file, जिसकी मैं अभी बात करने लगा हूँ आपके साथ. आप ये देखोगे कि मेरे पास ये है. I have the high-level language. High-level languages we always save in the form of, let's say, with C में कर रहे हो .c, Python में phy, JavaScripting में can save it as .js or HTML. So these are high-level languages extension files. Assembly language is always saved as .asm. Okay, the assembler basically converts into an object file. Okay, which is .opg save होता है. अच्छा, now ऐसे usually जो latest आपका हो रहा है execution, उसमें object file create नहीं हो रही. Directly assembly language is being converted into a machine code. Okay, but I would still prefer you to remain within the old school. Okay, क्योंकि CI भी तक ये use कर रहे हैं. तो हम object file को mention अभी भी करेंगे. मगर मैं बता रहा हूँ दोबारा कि अब assembly language का directly convert हो रहा है into the machine code. So object file को करना जरूरी नहीं है. In practical life बात करूँ, let's leave it because the book also has it. जी. Yes.
अगर अब ऑब्जेक्ट फाइल नहीं हो रही और डायरेक्टली असेंबली कोड से मशीन कोड है, तो असेंबली या लिंकर में से क्या यूज किया जाता है?
असेंबली और किसमें से?
यानी कि पहले असेंबली कोड से लिंकर असेंबली कोड से असेंबलर यूज करके ऑब्जेक्ट फाइल होता है और फिर उससे लिंकर यूज करके मशीन कोड होता है ना?
तो आप असेंबली कोड को हम डायरेक्टली लिंक कर रहे हैं ना, मैं आपको
तो
डेमोन्स्ट्रेट
हम क्या यूज करते हैं, असेंबलर या लिंकर या दोनों का मिक्स या व्हाट?
मैं आई वाज जस्ट देखो, while I will do all the discussions about CS, it's my job कि मैं आपको real facts भी बताऊं, ठीक है? मगर मैंने कहा कि हमने जो whatever you see right in front of you, this is what you have to use in the CA exams, okay? CA exam में तो अभी तक they are talking about technologies that are become quite obsolete. आपने input and output भी देखा होगा, मगर we still are talking about it. They still talk about TFT, which became obsolete 10 years back. So, मैं वैसे जनरली आपको बता रहा था कि अगर प्रैक्टिकल लाइफ में बात करोगे, आप जब जाओगे किसी प्रैक्टिकल लाइफ में सॉफ्टवेयर, उसमें यू विल नो कि असेंबली कोड डायरेक्टली मशीन कोड से लिंक अप हो रहा है. ओके, यू हैव गुड असेंबलिंग सॉफ्टवेयर दैट डोंट नीड दैट. ओके, इसलिए मैं इफ मैं एक्सटेंड से बात नहीं करता, इट क्रिएट्स कंफ्यूजन. ओके,
ओके
so we can
ओके, थैंक यू.
Yeah, we can stick to whatever is in front of you. Okay, so we have the object file. The object file is saved as .obj, and then you link कर देते हो. Then you have is the file name .exe. I think so. Now you have some idea that exe file क्यों बनाते हैं. This is why we have the exe file, so that when we install it, it can be distributed within the computer, and the architecture can understand it. Okay. I'm not explaining all this. मैं एक और जो बुक है उससे मैं आपको ज़्यादा explain करता हूँ. Hold on. That will be much more relevant than explaining you through this way. It's probably opened up over here. Yeah. So the machine code. Let me just discuss all this. It's important. Okay. I'll read and I'll explain. ये सारा आपको पता होना चाहिए. आप इसमें पता होगा आपको. Machine code is the programming language that the CPU uses. The hardware understands your zeros and ones, the binary. Okay. Instruction क्या होगी? Instruction is a single operation performed by CPU. Assembly language. Opcode में discuss कर लिया. Operand discuss कर लिया. मैं आपको example देता हूँ. इसकी source code, a computer program before translation into machine code, we call it source code. Just knew it. Okay, source code मैंने आपको दिखाया था. Yes or no? I was just showing you this. Okay, source code. Okay, so that's what I was referring to, the source code. Okay, assembler, a computer program that translates programming code written in assembly language into machine code. Instruction set is a complete set of machine code instructions used by CPU. Object code, computer program that after translation into machine code. So anyway, this will become too boring, but you will get used to all this, and you should know all these. आपको इसका आइडिया हो जाएगा सर. जी बोलो.
सर मशीन कोड और हाई लेवल लैंग्वेज में क्या फर्क है?
किसमें?
हाई लेवल लैंग्वेज भी तो नियरर टू द हार्डवेयर होती है ना?
No. आप are you comparing high level language with machine code?
जी सर.
Okay. Who would volunteer and try to explain? Anyone? Manu, Nisa? High level language or machine code को how do you distinguish them? Uswan? What's a high level language? Python, JavaScripting किसमें आता है?
Understood by humans, that is high level language.
High level language, exactly. It's a high level language. Okay. For the computer, for the machine, it's high level language. Okay. You up there, computer can't understand. They just don't get it. They don't understand what we're typing. Okay. It needs to be converted into an assembly language. It needs to be converted into an object code. It needs to be converted then into. Omano was not there. It needs to be converted into and machine code. A machine code basically though is what machines can understand. Binary, zeros and ones. Okay. High level language. जब मैं आपको ये दिखा रहा था बेटा, ये look at this one. High level language. This is where we have Python, JavaScript, and we program in high level language. We can also program in assembly code, like I told you. but we cannot work on machine code directly. It's next to impossible. Okay, you do not know how to do it. Okay, so an object file is basically, it contains the source code, and this source code comes from your assembler. So please don't confuse that object file is kind of a language. No, it's just an object code that has been compiled and is now ready to be processed by the machine code. Okay, so you don't program on within the object file. Okay, it's just an intermediate part, a layer that is there between the assembly code and the machine code. Okay, you program in high level, you can program in assembly, but you cannot program later on these two. You need to convert it into machine code. You get the point? Did I answer your question, Beta? Who was asking me? So high level,
Yes.
is it clear? We are going to join, obviously, once this gets off, we are going to join, inshallah. Okay, so let me get back. So I will be talking about all this later. आपको जब मैं कर लूँगा, आपको idea इसका वैसे ही हो जाएगा. So this is what we have. If we have LDD total, so this is we call this the opcode. This is the command. This is the instruction that we're giving. This is the operand. Okay. So this is the machine code in hexadecimal. It will look like this. So let me give you more example. So, example, if I say LDD, it means load 200. Okay. Command 0, jump not found, jump if you have found it, jump away if you do not found it, out. There are lots of commands that we will practice with right now with the past paper. So we have this over here. We have opcode LDM, load the number, hashtag. When you have hashtag number, it means you have to load the number into the accumulator. Remember accumulator? ACC stands for accumulator, ACC. Okay. So accumulator will hold all those mathematical calculation numbers and all that as a register, as an intermediate place, so that further calculations could be done on them. Okay. Immediate addressing is used. LDD, basically, LDD address means load the content of the specified address into accumulator, which means you have to load the content of the specified address. So you have an address, and that address is pointing towards a content. So what we're saying is you have to load the content which has been specified by an address into the accumulator. Get the point? Okay, this could be direct or this could be absolute addressing. So again, we'll talk about direct and absolute, not today, afterwards. So then you have LDI. The address to be used is the content of the specific address, loads the contents of the given address into the accumulator. Okay, ये सारे भी हम पास करेंगे, उसमें आप clear हो जाएगा. LDX, the address to be used in specific address plus the content of the index register, load the content of this calculated address into the ACC. बल्कि काम करते हैं, हम एक पेपर कर लेते हैं, उससे आपको ज़्यादा clear हो जाएगा. You might be saying कि इतनी जल्दी से पेपर कर रहे हैं, because I'm telling you this part is not tough. You will find it. Let me discuss with you. नहीं आता तो we'll discuss it again. ये जो सारे discussion है ना, all this comes in the paper and it's pretty easy. So we will be able to finish all this today. Let's कौन सा करेंगे? मैं आपसे दो मैं सॉल्व कर देता हूँ आज. एक मैं आपको I'll give you for the class work right now. अच्छा. Yes, question number 9. Okay, it's a lengthy question. Third time लगेगा, but let's do it. Okay, so let's
टोटल कितने मार्क्स का है?
क्या बेटा?
ये टोटल कितने मार्क्स का है इतना लंबा?
देख लो 2 3 ये 10 मार्क्स है, ये 10 to 15 मार्क्स का आता है।
ओके
हाँ 10 to 15 मार्क्स का आता है, जस्ट लाइक जो आपका जावा का आता है। ओके लेट्स स्टार्ट विद दिस। इससे पहले लेट मी जूम इन। Okay, the table shows assembly language instructions for a processor which has one general purpose register. Okay, okay. One general purpose register, एक register है, the accumulator and the index register. ठीक हो गया, ठीक हो गया, ठीक है. And this is the opcode instruction. This is the operand. Okay. Operand मतलब does it hold? Does it hold an address? Does it hold a register or whatever? ठीक है. ये इसकी explanation है. What does it do? So this always will be provided to you during the exam. So it doesn't mean that you have to cram it. कोई जरूरत नहीं है. Okay. Eventually वैसे आपको पता चल ही जाएगा इंशाल्लाह. आपको ऐसी ज़बानी याद हो जाएगा what do. But let's say you're not supposed to know what they are. Let's have a look at this one. The diagram shows the current contents of the section of the main memory and the index register. ठीक हो गया? ये आपका index register है. So if I say this is my index register, what content does it hold? इसमें क्या डायनरी वैल्यू या डेसिमल वैल्यू कंटेंट क्या पड़ा हुआ है इसमें?
सर ये बाइनरी नहीं है?
बिल्कुल है. मैं आपसे ये पूछ रहा हूँ ना, इसमें कंटेंट क्या होगा इसके अंदर फिर? अगर बाइनरी है तो इफ आई कैन अगर कन्वर्ट इनटू डेसिमल तो इसमें क्या कंटेंट पड़ा हुआ है? व्हाट डू आई? बिल्कुल 8 1 2 4 8. This is 8. Agree with me all of you? This is 8, right?
Yes.
Okay, right. बिल्कुल ठीक हो गया. So you do know कि at the following address location, following location पे what contents do I have? Any problem in that? Right? No. So let's look at the first question. Show the contents of the accumulator, okay, over here, after the execution of the instruction LDX60. Okay, now you don't know what this is 60, but what is LDX60? Okay, right. Let's have a look. So LDX basically means what? Indexed addressing. Form the address from the address plus the content of the index register. Okay, so let's do this first. Okay, what we need to do is, so form the address from here LDX60. तो 60 पे क्या है? 60 पे I have this. Okay, I have the following number. So what it's saying is form the address from the address plus the content of the index register. What is the content of the index register? 8. So 8 plus 60 is how much? 68. Did you get my point?
Yes, sir.
Please, all of you, please read this. Why did I say 68? मैंने भी ये part किया है. Form the address from the address. Okay, पहले करो address को plus address क्या है? 60 is the address. 60 is the address plus the content of the index. The content क्या है? Index इसका content क्या है? 8 है ना? The content is 8. So 8 plus 60 is 68. ठीक हो गया. फिर वो कहता है copy the content of this calculated address to accumulator. Okay, which means 68. 68 जो मेरे पास आया है, इसका जो भी content है इसको डिस्प्ले करा दो इधर. You get the point? So what will I have? Can I write down?
सर हम ऐसे नहीं कर सकते, हम दोनों की बाइनरी को लेके ऐड करें, एडिशन करें और उसके बाद आंसर लिखें.
नहीं बेटा, वो इस तरह एलडीएस काम नहीं करता. एलडीएस जाता है, एलडीएस पहले जाता है उसके एड्रेस पे जाएगा 60 जो भी है, ठीक है. उसके फिर इंडेक्स रजिस्टर पे जो होगा उसको कंटेंट में कन्वर्ट करेगा. उसके डिक्शनरी वैल्यू में, उनको ऐड करेगा एंड देन दिस इज हाउ इट वर्क्स एक्चुअली। ये एक्चुअल आपकी असेंबली लैंग्वेज का है। This is not just an abbreviation. These are your actual commands of assembly language. Okay?
सर
जी।
मुझे सारा समझ आ गया, मुझे accumulator समझ नहीं आया कि accumulator exactly क्या होता है।
Accumulator होता है आपका टेम्परेरी, एक टेम्परेरी फाइल है, टेम्परेरी जगह है जहां आप डेटा को रख रहे हो और बाद में आप उसको यूज कर रहे हो। An accumulator was the part of the processor that is responsible for mathematical calculation, for comparisons and all that. We call it accumulator. It's a register. Index register याद है?
ये
Index register was
पता
हाँ, इंडेक्स मैंने याद है, मैंने आप लोगों को कहा था कि इंडेक्स सिस्टम में आगे जाके डिस्कस करूंगा, सो उसकी डिस्कशन अब आ गई है ना।
ओके
रिमेंबर मैं लास्ट लेक्चर में कहा था कि जब इंडेक्स की बात हुई थी, आई टोल्ड यू कि इट्स एज अ पॉइंटर, इट टेल्स यू, इट पॉइंट